This video is sponsored by PCBWay. More on them later. Hello and welcome to another episode of Statomatic Science. Today we're going to be taking a look at my automatic turntable again, the STM01, and specifically we're going to be improving the visual aspect a bit. For those who are new to this channel, this project encompasses my quest to design a fully automatic turntable from scratch. As it stands, right now, the tone arm is finished and I have it lifting up and down, and I can connect to it from my computer and execute commands, pull statistics from it, and do other troubleshooting. In this episode, however, I'm looking to give the user interface a little bit more attention. This prototype tone arm mount and free-floating buttons and LEDs do their job, but it would be a little bit easier to tell what's going on and to know what buttons I'm pressing if I had a real user interface to poke and prod at. So, let's do that. Now, when you heard me say user interface before, basically what I mean by this are the parts of the turntable that the user will interact with to elicit some kind of feedback. For example, on my Technics SLD2, the user interface consists of an auto return button, speed selector, and fine-tuning speed control. I'm not really including stuff like the turntable and tone arm in this equation, just the buttons and LEDs right now. In my design, I came up with this general layout for the user interface. Basically, we have our power switch, or button, whatever I feel like putting here, and two command buttons, play and pause, and two setting buttons, size and speed. Pause I implemented in a previous video, and I have the rest of the buttons also connected through a multiplexer, but they don't do anything yet. Additionally, each of these will have an accompanying status LED associated with it, which is another part of this user interface I'd like to nail down. Now, in an earlier episode, you might remember that I went over a plan for the back of the turntable as well. This is technically also part of the user interface, though I'm not going to worry about that in this episode. Today, we're just going to be focused on the top. So as it stands now, we have input buttons and we have output statuses. We just need a way to organize them on the user interface for the user to look at and know what's going on. In my very first turntable prototypes, I used cardboard to cut out roughly what I wanted the turntable's user interface to look like. In this design, I figured I would utilize the software side of things a little bit more and design an aerial view of the turntable to help me with this layout. So I followed that up with taking this part here, which I'm calling the UI plate, and 3D printing it out in two pieces. This piece gives me a real feel for how the user interface is going to feel. I also designed some buttons, button holders, and indicator holders that will sit in each of these holes. The buttons just slot right into the Cherry MX key switches, which get mounted under each of these holes and set in place with slotted screws. And yeah, after playing around with this for a bit, I'm pretty content with how this user interface feels, but I'm not really content with how it looks. So I exported these models in one piece so they could be cut on a laser cutter and etched with a laser etcher. Now how did I do that? That's where today's sponsor comes into play, PCBWay. Now let me tell you a little bit about PCBWay. If you look at a project like this automatic turntable and think to yourself, man, that does not sound attainable at all, I don't have any of the tools to do that. Well, PCBWay does have those tools. PCBWay provides all sorts of services, such as PCB manufacturing, including assembly and SMD stencils, as well as CNC routing, 3D printing, sheet metal fabrication, and injection molding. And if you don't know how to design a PCB, they can even do that for you. Now, for my project here, I opted for sheet metal fabrication. All you have to do is design and export your part using your favorite 3D modeling or CAD software. Then upload it into PCBWay and go through the form and fill out the specifications you want them to follow. After you're done with that, you can just submit your request, they'll provide a quote, you can complete the purchase if you choose, and they handle the rest. So once your order is placed, all you have to do is sit back, relax, and wait for your parts to show up. So next time you find yourself at a standstill with one of your projects where you don't have the proper machinery to accomplish something, maybe give PCBWay some consideration. Just follow the link in the description below for a free $5 when creating a new account. Thank you PCBWay for providing this part for the channel. Anyway, back to turntable land, this thing looks awesome, and seeing all the buttons and indicator skeletons in it make me really excited to have this thing finished. So now we have a layout that I think looks pretty good. We need a plinth to put that in. Granted, this isn't going to be a complete plinth because we don't have a turntable yet, but we can at least design the parts aside from the turntable. I did this by picking my most warped piece of thin plywood that I could find and cut it down to size on the radial arm saw. This is going to be the top of the plinth. Remaining dimensions I cut on my table saw, trying my best to flatten the wood out with my weight. Next, I grabbed some scrap plywood and cut this down to size. This will eventually become the sides of the plinth. My goal is for the top of the plinth to sit flush with the sides. So I cut out a little notch on each piece just by running the piece over the blade and adjusting the fence slightly. The only thing left to do before we can do a dry fit is cut 45-degree angles on the pieces. This is the second time I'm attempting something like this. The first time I tried this for a different turntable's plinth, I completely destroyed the corners. And I tried to save that project by cutting them out and sticking other wood in them. Honestly, it came out kind of cool in the end, but I don't really want to do that here. After they were all cut, it looks like my cuts came out a lot better than last time, so I'm glad to see that I improved at least a little bit. Even better, my dry fit is looking extremely promising, as long as you can ignore the slight warp in the top plywood. But I think that's going to be fine for a prototype. The biggest challenge of this thing was gluing it up, since one end is open, so I couldn't really use my box strap. I ended up just pushing the corners together, which got it close enough. If this thing falls apart, it's not a huge deal, it's just a prototype after all. After that dried off, I tried fitting everything together, and it still fits, so that is wonderful news. The last thing it needed was a little bit of sanding to clean up the outside, and then it got a healthy dose of stain to help the plywood be a little more photogenic. Truthfully, I thought this was going to make it look awful, but after doing that, I found that I kind of like the look of dark stained plywood. To cut out holes on the top panel, I made this stencil, which let me trace where I want the cuts to be. From there, it was just a matter of drilling around the lines on the drill press and then cutting out the larger chunks with the keyhole saw. After I had that done, I assembled as much as I could just to get a feel for what I'm working with, and I'm pretty content with how this is shaping up so far. Except these buttons feel terrible. The Cherry MX key switches feel great, but you can hear the 3D print layers grinding against the walls of the UI plate. To solve this problem, I bought some cylindrical aluminum machining stock. Now, I don't have a metal lathe, so I made sure to size these holes based on the off-the-shelf measurements of these pieces. All I had to do was cut them with the hacksaw and grind each side as flat as I could get them. To really brighten things up, I painstakingly sanded each of these pieces and then ran them on the buffer, which was absolutely terrifying, by the way. I never got them perfect because I would have needed to go a little bit longer with the sanding step, but they're shiny and look good enough from a distance, so that's good enough for me. The other sides of each button got super glue, which was glued to this 3D printed piece, which will couple the aluminum cylinders to the Cherry MX key switches. Giving these things a test, and they feel awesome. So much better than the 3D printed buttons. They feel heavy and still make a really satisfying click. Now, you're probably looking at these things that I've been calling indicator holders and wondering what is even going on with these. On my previous prototype turntables, I just had LEDs protruding through the top of the turntable, which works just fine for a prototype, but for the real deal, I wanted something that looks a little bit nicer. One thing I experimented with before with success was putting displays behind tinted plexiglass, which gives a pretty clean look. So I wanted to try this with single LEDs to see how it would look. I did this by printing a couple layers and then swapping out the filament colors during the print. My first attempt at this had 100% infill with clear filament, with the expectation that the clear filament would diffuse the light, but what actually happened was no diffusion and the display was way too dim. So after a ton of experimenting, I settled on a hollow design which turned out much brighter and looks just as nice. I had to do this 4 times, 2 for each setting display, and this filled out the bottom row of the displays. I had to give the top row a slightly different shape, so then I did this 4 more times to get the top row. And I had to paint the black foreground with more black to fill in any holes that the light could get through. Anyway, once I was able to test all these indicators seated inside their enclosures, I was really happy with how they came out. I think these things look really cool. Up until this point, I hadn't implemented any kind of functionality for these speed or size buttons, so I spent some time coding that up just so I could give this thing a test. And yeah, that is getting me excited about this project, even though they technically don't do anything yet. Now, the last thing I had to do was make these indicator holders a little bit nicer. I originally attempted to acetone smooth the ABS print, this time using heat from the print bed as a catalyst, but once again it made absolutely no difference. So I ended up dunking the part again, and that's why it looks particularly awful. So I gave up on this and bought an SLA printer. I figured if I'm going to need this anyway in order to print the encoder code wheel, I might as well learn how to use it on a less critical part first. I experimented with this for a couple days and was absolutely stunned at how the prints came out looking. They're so much higher quality than the FDM prints. I never got things coming out absolutely perfectly, which you can see by the warps on some of the prints, but I think they came out nice enough, and I'm content with them for now. That gave me a solid starting point for sanding, and then spray painting. I did an absolutely terrible job keeping dust out of the paint, so I'm going to need to figure out a way to deal with that eventually. But it came out pretty glossy, so I'm content with it for now. My goal in this episode isn't to get the UI looking 100%, but maybe more like 75%. because I know I'm going to have to take it apart countless times anyway down the road, so I'm probably going to scratch and scuff the parts up, so they don't have to be perfect for now. With all the parts designed and finished to my satisfaction for now, it was time to assemble everything. I started with pushing the digits into the indicators and then screwing the indicators into the plinth using these brackets I made. The other half of the build involved me removing the tone arm from this test rig I set up before. Just gotta desolder these audio wires and unscrew one screw from the back of the tone arm assembly. And it lifts right out with ease. To remove the tone arm rest, I had to punch it because it was glued. And lastly, the bottom plate could be unscrewed from the bottom with these 4 screws that were threaded directly into the plywood, which allows me to remove that inner assembly. Now, on the new plinth end, I don't plan to screw this plate down because the plywood is just too thin, so I'm gluing it down. Fortunately, I can still unscrew the azimuth and elevation modules from this plate, so nothing is permanent here. I screwed down the tone arm rest instead of gluing it this time, so I won't need to punch this off anymore, and then threaded the tone arm's wires down the shaft and screwed it into place. And with that, we have a fully assembled, so far, Statomatic STM01 turntable. So here it is, in all of its incomplete glory. The pivoting part of the tone arm is sitting quite a bit higher than it was before, but this is just because I originally measured this using the thickness of the plywood from before. So in the next episode, I'm going to correct this. The counterbalance weight also spills off the back of the plinth quite a bit, but once I make a weight out of steel, I don't think this is going to be a problem anymore. But anyway, we can flip through each of the speed settings and each of the size settings, which, in my opinion, these buttons give a pretty satisfying click. Power switch does nothing, play button does nothing, but the pause button does do something. The exact same thing as it did before. And don't worry, I'll show a video of it playing a record here. Even though you can't listen to the music because YouTube is really strict about that. To be honest, I don't know why big music corporations wouldn't want free music advertising, but those are the rules, so I gotta follow them. But yeah, I will admit the color scheme I picked for the indicators doesn't look as nice as I'd hoped, but it's certainly a unique look, so I'll take what I can get. Maybe I just gotta learn how to paint better, I don't know. These things do really look bad in the wrong lighting, but that's gonna be a future endeavor. It's good enough for now. Well, there you have it. The STM01 looks a little bit nicer, and I'm pretty happy with how it came out. Even though it has its imperfections, I think overall it looks pretty nice. Also, keep in mind, this entire project is open source, so if you want to look at the code, schematics, models, diagrams, any of that stuff, feel free to check out the GitHub link in the description. I have a running checklist of things I know I'll need to complete this project, and in this episode, I got to check this one off right here. I just think of this as a fun way to monitor the progress of the project. Now, in the next episode, I'm planning to do some really exciting stuff. I want to get the azimuth movement automatically working. So you press a button and it plays your record automatically. Yeah, we are finally going to be doing that. This automatic turntable is finally going to actually be automatic. Just not with a turntable. Yet. So feel free to subscribe and join me on this journey if that sounds interesting to you. Anyway, thank you so much for watching, and I look forward to seeing you in the next episode.